Real-time feedback into the behavior of your distributed systems and observing changes, exceptions, errors in real time allows you to not only experiment with confidence, but respond instantly to get things working again.
Hi, let's start from some easy example which is not documented in TypeScript documentation, but I have found it very useful. So currently you all know that we have lowercase built-in type which will just lowercase your string. For instance, let's try it. Type test equals lowercase, for instance, a. Oops. So test is equal lowercase a. So previously, if you provide lowercase string, it will do nothing, because string is very general type. It's hard to imagine how we can lowercase any string previously. However, after TypeScript 4.8, you are able to use lowercase with common type, with general type string, and you will get an error if the string will be uppercased. For instance, we have our string str variable, which should be only lowercased. Here we have OK, here we have an error because of how it works now. As for second one, also undocumented feature, at least I didn't find in documentation explanation of this behavior. However, you can find some explanation here in this Stack Overflow answer and in my article in my blog, undocumented features. You can find my blog here, catch.ts.com. Okay, so what about inference prioritization? Just imagine that we have some props, select props, which expect value generic, which will be used for value and for options. And then we have just, I don't know, any React component select, which will infer provided value. So here you see I have provided generic constraint that value should extend string, and our props will be select props with this value. Current constraint is that if options, that value should be one of options. So for instance, if options are red and yellow, value accordingly should be either red or yellow. So this is okay. However, what about this? It is obvious that this component, that these props are wrong, because value should be either red or yellow, and in this case it is green. Why? So currently it just should work as it is, because value is just an inference of your props. So if you provided a value green, then it is perfectly fine. So as you might have noticed, value is red or yellow or green. If you want to make sure that value should be only red or yellow, you should just add this small sync. Boom. This means that prioritization of inference of value is lower. It means that first of all, we will infer a value for options property, and only then we will infer for value. So once we have inferred red and yellow for options property, TypeScript now is aware that value should be either red or yellow. Apart from that, using this using intersection with empty object also is interesting, because it means that it is non-nullable value. It was provided in, I don't remember, TypeScript 4.8 or 4.9. Sorry, don't remember exactly. But they even replaced non-nullable built-in utility type with intersection of generic tag and empty object. So now, as you see, null is highlighted as never, and if I will provide 2, it is okay. For instance, array, it is okay. So, it was very interesting for me to see that this small trick can be used for both cases, and furthermore, it's at least this behavior is not documented, and it is, I would say, very unknown feature, but very useful. So let's go to our next section, useful patterns. It is how to say, it is very, I would say it is very popular question on Stack Overflow. This example, imagine that we have some object, I don't know, some dictionary, doesn't matter, and we want to create a function which expects this object and property which corresponds, for instance, to strings. What I mean? I mean, if we have this object where A and C properties are strings, then our function should expect only A or C properties. We are not allowed to provide B property. So here we should get an error. But this string property is not implemented yet, so there is no inference here at all for now. So let's create our utility types to accomplish this task. So first of all, I have created values with just this utility type. It is very popular utility type, and it just returns us a union of all values. What does it mean? Type test equals values type of object. Oops. So it is string and number, because union of all values. If I add it as const, I will get A, 42, and C. Yes, just union of all values, nothing complicated, I would say. As for this one, filter property by object and type. This is also, I would say, popular utility type. It iterates through object and checks whether object value extends some type. For instance, in our case, we are expecting here that if object property extends number, we will return this object property, otherwise we will get never. So we just filtered object properties by type. For instance, here I get B only because I have provided a number. If I will provide a string, I will get A and C. So pretty straightforward. More explanation you can find, as I said, on my blog. So let's try to implement our function. So here I have provided two generics for type inference. First one is object, which should be a subtype of record where each property is allowed object key, string, number, symbol, and value is unknown because it doesn't matter for us which value should have this object. And as for key, it is like our most interesting part. We are calling filter property by I provided object and string. It means that I want to filter object keys by string. Now this intersection is very important because without it will not work. As you see, I have an error here. It says to TypeScript that, hey, this object which is provided by you has a key which corresponds to string. This string and this string are should be like the same type. It means that if I will call this object with key, it allows me to use any string prototype method. Charcode add includes index of. So as you see, it works for outer world and for inner, not world, but scope, for function outer scope. So you are allowed here to provide only allowed key, and for inner scope of function. For instance, if I provide here a number, so we want a number. C is not allowed anymore because it should be only B, because we have only one number property, it is B. So it is allowed us to use B. And here we are allowed to use to exponential, to fix, to local string. So all number prototype methods. Okay, let's go to another example. Believe me, people are asking on Stack Overflow once per week why array prototype includes doesn't work with tuples. I mean with immutable arrays. I will not provide you with explanation why. You can easily find it. It is very popular. I want to provide you with solution which without type assertion. I mean without using s assertion. So currently, if for instance you have some immutable array and you want to check whether it includes D, you will get an error. So how we can fix it, how we can write our code more safer? We can carry it. So we can make a function which returns a function. So what does it mean? I have created a function with tuple. I have provided a generic parameter list which extends an array of strings. And here I have just provided this type. I have used this REST operator for type inference. So currently nothing complicated. As for the second one function, which is returned function by this, remember we have here we have two functions, is a type guard. What does it mean? It means that it expects us one argument which is prop, which is string, and if it returns true, it means that prop is a part of the list, is the element from the list. Just want to remind you what this syntax means. if we have a tuple type with square bracket notation where we just use a general type number, it will return us a union of all tuple elements. What I mean, I will just provide you with small example just to have an overview what we are doing here. So type here and 1, 2. So this is our type. Our type is tuple, which consists of 3 elements, 1, 2, 3. If I use square bracket notation and will type a number, it will return us a union of all elements. Okay. So now when we understand what's going on here and here, we can use our utility function. First of all, I have created includes function. Please be aware that includes is a function because this tuple returns us a function. It means that includes checks whether prop is one of tuple elements. In our case, ABC. So here you were not allowed to use like any other string except ABC. Here we are allowed to use any string because prop is actually a string, so it might be any string. And here after we apply if condition statement, str will be A, C, and B. Okay, let's proceed. Let's go to our next section. It is safer TypeScript. It is very, very easy thing, and you need to be aware that using interfaces in TypeScript is more safer than using types. There are a lot of discussion you can find in internet that I prefer to use types, I prefer to use interface, somebody prefer to use anything else. It is, I would say, in TypeScript, it is not a matter of preference whether you want to use interface or type. It's a matter of, I would say, safety, or it's not to be. It shouldn't be. What I want to say, it shouldn't be a preference. It should be a rule that if you have some object with some predefined properties, like you have here, we have an interface animal tag name. We can use generic type here. In this case, it's important that it is that we are using an interface and not type. We should use type for aliases, for some making fun utility types, some iteration, but not for declaring just a shape of object. Why? Just imagine that you have a type animal, and you have some function handle record, for instance, which expect as an object where key is a string and value is unknown, and this object will be mutated. So imagine you have some generic function which mutates your object. I don't want to say that mutating objects in TypeScript is a very cool idea. However, we might have it. So if you have this function, and it is perfectly fine that you are mutating object here, you can assign any value, like 23 or I don't know, some array of numbers, and it is okay. TypeScript perfectly fine with it. Furthermore, you have an object which is an animal, and you are passing this object to this function, and this object will be mutated. Like, just ask yourself, is it okay that I can mutate any object in my application? For instance, okay, I know you are not mutating your object, but maybe your colleague mutating it. Or maybe when you leave your project and 1 year later somebody will join your team who likes mutating objects, and they will probably mutate it. And it is not okay that animal is mutated. So if you use here an interface, TypeScript will disallow you mutating of this object, because when you write interface, you write sealed. Okay, sealed, it is not TypeScript keyword, but TypeScript treats it in this way, that this object can't be extended, can't be changed. It is like interface. I would say this is very important, because I have seen a lot of examples with mutating when people are using types, and believe me, it leads to some runtime errors or production bugs. So it is very easy to remember and very important to use. And what's also important, why this happens? Because interfaces are not indexed by the default. This is the difference between interfaces and types. Types are indexed, interfaces are not. Okay, let's proceed with our next section. It is recursive data structures. In previous TypeScript versions, you were not allowed to compute TypeScript range of numbers. You were allowed to create range for 40 elements, something like that. Currently, after optimization of tail recursion in TypeScript, you are allowed to create up to 1000 numbers. Oh, it should be. Let's try 999. One more small improvement. So as you see, you have a number range of 100 digits. Why 100? Because we start from 0. Sorry, no 100, but almost 1000. Okay, this was just for testing. I will explain how it works. Sorry, here we have a recursive utility type, which expects us 2 arguments. One, n, corresponds to our count of numbers, and second one is result, our array of numbers. When we call it, we are checking whether our length of our result, length of this tuple, extends our expected length to be created. If yes, we will just return a union of all elements in an array. Otherwise, we will run compute digit range, this utility type, with same argument n, and with extended result. So every time we will add to result, results length. So it starts from empty array. Imagine that n is 5. Let's start our first iteration. Result length is 0, extends n false. We will go here, and here we will add result. It is empty array. It will just get rid of it. And second one, result length is 0. However, it will be an array of 1 element. So next iteration will be result length will be 1. This is how we increment. Okay. Also, very popular question, how to create repeated string with which matches some pattern. For instance, we are not allowed to use regex patterns in TypeScript template literals. However, and also we are not allowed to create some infinity string type with some repeated pattern. It would be nice to have it in TypeScript, but currently we don't have it. How we can make it works? For instance, we have some type coordinates. This type corresponds to number which are separated by comma, and the coordinate string is separated by a semicolon. I mean, this is our example. This is our type of coordinates. But what if I want to make it longer? You will get and here, for instance, I expect this. We are getting an error because it's obvious. What we can do, we can recursively, we can apply this utility type, like apply this algorithm. I don't know what is better to say, algorithm or pattern. And we can recursively create up to 50 or 100, I don't remember exactly, up to 100 unions of different sizes of coordinates. What I mean? Please, here I have created compute coordinates with 10 iterations. Sorry, no iterations, but with 10 elements. So this type allows me to use coordinate where I have only 2 numbers, then when I have 4 numbers, then when I have 6 numbers. So as you might have noticed, I don't have 3 numbers, 5 numbers, because it doesn't make sense, because our coordinates should be atomic. So it should consist of 2 numbers which are separated by a comma. How does it work? Works very similar, but it only differs how I compute the value which is pushed to our tuple. Here I'm using concat previous. It just takes last element of my result and concatenates it with new coordinates. So this is how each iteration coordinates is made one coordinate more. Here you can find links to articles with more explanation, because I understand that it might be hard to build all to understand how it works only from this video. For instance, I prefer reading articles rather than watching video, but some people may prefer watch video. Okay, so once we have finished with this pattern, I believe we can proceed to hex validation. I will show you what I will do at the beginning, so you will be aware what I'm talking about. I'm talking about a function which expects us some object where key is a color name, but in this case it doesn't matter whether it is color name or not. No. And the value should be a valid hex value. Valid hex value can consist of either 3 chars or 6 chars. Furthermore, these chars should match some pattern, because you are not allowed to provide just 6x. It will be an error. So let's start typing this function step by step. So first of all, I want to compute a range of numbers from 0 to 9, which are please keep in mind that these numbers are only allowed in our hex, but it also all number which you which you can use. You are not allowed to use more than that. So currently, as you might have noticed, I just wrapped this range in a template literal string. So each number is a string. Also, I'm allowed to use chars from A to F, A, B, C, D, E, F, only 6 chars. And they might be lowercased or uppercased, so I just used the built-in utility type uppercase. So I have a union of my chars, lowercased and uppercased. And this is my final hex value. I mean, not hex value. I mean, all chars or all digits which are allowed to use in our hex string. It is from 0 to 9 and from A to F, uppercased and lowercased. So imagine that you need to write a function in JavaScript which will validate it. Please forget for a moment for bit validation, for some bit manipulations. Let's just stick with raw string. So currently, since our hex value can be either 3 of 6 elements, we can what we need to check whether string length is allowed. In order to do that, we need an utility type which will return us a string length. This is why I have created this simple utility type, recursive utility type, which iterates through each char and every time adds this char to accumulator. So at the end we have a tuple which length is equal to string length. So in our case, this will be 3 or 4. Okay. The next step, we should validate whether it is 3 or 6. Let's write very simple validate length utility type, which expects us our string and our expected length. And here we are checking whether string length of provided strings extends length. We will return string. Please keep in mind that always when, in this case, when it is awk, we are returning string, not true or false, just string. It is important to be in mind. Otherwise, we are returning never. So here, if string is ABC and expected length is 2, we will get a never. And here we are getting ABC because expected length is 3 and we have 3 chars. Okay, I hope it's easy to understand. Let's proceed. Here we have validate hex. What these utility types do? It iterates through string, like through each char. Here, how we are getting like each char, and here we have a rest char. So every time we pick one char, and then we are checking whether this char extends our hex value, extends our allowed hex value from 0 to 9 and from A to F, uppercase and lowercase. If yes, we will add this allowed char to our cache here. Otherwise, it will be never. So here you can check how it works. ABC each char is allowed, so it returns as ABC. Second one, each char is not allowed because it XXX. It's just not allowed. Okay, what are we doing next? It is very important to understand how it works, because currently what we are doing, we are just using all our validators, and we are making intersection of them. Why we are making intersection? Because each validator returns as either string, provided string, or never. So in case if it returns string, provided string, and intersection of equal strings will just produce this string. Otherwise, it will produce never. So you can have, I don't know, 20 validators where each validator returns you a string, either string or never, and just apply these validators like that. Validate something else. It will be easy to read, easy to understand, no more cryptic types. So here, if imagine you don't know TypeScript, validate hex, validate length. At least we are aware that here we are doing hex validation and length validation. Here I am using union because string length might be 6 or 3. Second one is just adding this fancy hash symbol to each property. And then this is how this function works. I use type inference or on function arguments, so I have created 3 generics. One generic for key, object key, second one for object value, and third one is our color map. So color map should correspond to this object. And this is wrapped into my validator. And that's it. This is how it works. So here you see that if I use invalid hex value, it will return me an error. Otherwise, it works as expected. So one more thing that we need to use like extra function for type inference. We are not allowed to use just standalone object. We need to use this function despite the fact that this function do nothing. So it just returns as a dictionary. That's it. Thank you very much for your attention. See ya. Bye.